So in this video we'll take a closer look at this Intel NUC. This is the Intel NUC Enthusiast. This is the 11th generation. So it is a few generations behind the current one, which is of course the 13th as of recording this video. But right now you can just get these so inexpensively. They are like below 50% of its MSRP. It does have a built-in NVIDIA 2060. And for me personally, I just plan to use this at a little transcoding server, or maybe just a little computer for my office, a little power efficient computer. But my main goal is to run this as a TDAR server, so it can transcode all the media I have on my NAS servers, because I have a lot of video files there, not only for YouTube, but home videos and so on and so on. So setting up a TDAR server, it can just transcode all those videos to H.265, and I'll save a lot of space doing so. Currently, I have my 4090 in my main gaming PC set up for that task, but would be nice to have a dedicated server that I can put in my server shelf and kind of just forget about it. I don't have to think about fan noise or anything like that. Or like I said, maybe I'll use it in my office, install Windows, and just install TDAR using Windows, which actually works quite well on my other PC. But anyways, in this video we'll just unbox, we'll just install some memory kits that I already have lying around, and I do also have a few SSDs that I want to attach to this little computer here. Taking a look around the box, nothing really interesting at the bottom. On the side here, of course, we do have an i7 inside. This is only a quad-core CPU, so not the most powerful CPU, but that's both a positive and a negative. On the positive note, it doesn't run as hot as like a 8-core or a 12-core or whatever they're up to nowadays. So it's actually supposedly very quiet in operation. And the bad side, of course, is if you do multi-core tasks, this is not going to be the fastest at that, but I do not plan to really. So it would be fine for me, hopefully at least. But we do have that nice 2060 NVIDIA RTX in here. So it's not as powerful as a real or a desktop 2060, but it's more than sufficient for just transcoding H.265 videos. We do have two Thunderbolt 4 ports that's on board. Mini display port 1.4. I believe you need to use the mini display and or the HDMI out if you want to use the inbuilt graphics card. If you want to use the Intel Iris Xe graphics that's built into the CPU, you need to use the Thunderbolt port, and of course use either adapters or whatever to hook those up. We do also have USB 3.2 Gen 2, so these are 10 gigabits per second, and we have 6 of those. All of them, I believe, is USB Type A. And what's very nice about this one, it does have an Intel 2.5 gigabit Ethernet port as well. Would have been nice if it had two 2.5 gig, but it's very easy to use an adapter like this. This is a 2.5 gig to a USB-A NIC, so these work quite well in my experience. So if you want to run like virtual machines or so on and want to pass through a dedicated NIC for those, you can of course just hook up a USB NIC. We do have Wi-Fi 6, so not 6E. This is just a generation before that, but it's definitely fast enough, and Bluetooth 5.1. Don't plan to use that personally, but I believe it is soldered onto the motherboard, so we cannot really replace that, which is a little bit of a bummer. We do have a touch link, of course, for audio out, SDXC slot, which is USB 2 compatible. So that means you can use faster SD cards in this one, and even maybe expand the storage a little bit that way. And you do also have a vertical stand included. And what's needed is, of course, DDR4 memory. Like I showed you before, I have a 32 gigabyte kit, Kingston Fury, that I've had in multiple other systems by now, but this is a very good kit, and this is dual rank as well, which is kind of hard to get nowadays. And I have two 1 terabyte SSDs that I'm also going to throw in this one. And you do support 2 NVMe SSDs or 1 NVMe and 1 SATA disk, so you can kind of pick yourself, but that's kind of nice. So you can have like a RAID 1 or RAID C1 configuration, which I am planning to do in this system. And of course, the other side here shows you all of the ports. I really like this design and all layout as well. It's a little bit industrial, but also of course a little bit gamery in design. So you have plenty of ports on the front and plenty of ports on the back. And of course, we'll just take a look at that when you actually open it up. And man, this box is just so heavy, so it feels like there's a lot of good stuff in here. So let's just cut through the seal. This is of course brand new, and I think the stock of these is about to wear out, because here in my country there's no really anyone selling it. So I was lucky to get one of the last ones here in my country for, like I said, below 50% of its MSRP. And how do we open this? And of course we need to open it this way, I suppose. So actually quite a nice unboxing experience. So it's magnetically held in place, and you kind of just open it like a folio case here. And on the inside we do have that Intel skull nicely laid out. I really like Intel unboxing experience. I think they do kind of a good job with the packaging. It's kind of the border of being industrial, but still they have like all of these Easter eggs. For instance, the skull like inside the lid wasn't really necessary. It's a nice little added bonus there, at least when it comes to unboxing experiences. I think it's kind of important that you feel like you're buying something substantial. Then of course we have the NUC, and man, that thing feels very heavy, very nice, very dense little box. I've been very excited actually to get this one. Took a few days for it to arrive. Inside the box here, we do have some safety information cautions. I believe these are just mandatory that they have to include. I don't think anybody would really read these, at least I have never read them. Let me know down in the comments below if you actually have read those safety information that are inside the packaging, no matter if it's from Intel or whatever. And this is regulatory model, blah, 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 blah. Nothing really important there as well. Then we come to the actual instructions. And Intel always do a nice job here. I'm kind of sad to see them actually leave the NUC brand or discontinue the NUC brand. I really like that brand and the products as well. But anyways, here we of course have all of the information about the product. You can see there in many different languages. And it also takes you through how to actually remove and also how to install like SSDs and also memory. You can also actually use a little bit longer NVMe SSD in here as well. Also says that you should not use a power tool, which I definitely do agree. And I believe they do have the included tools for you to actually get in there. Also have a VESA mount and also the stand and a pretty beefy power supply as well. That should be pretty straightforward. I don't think really I need to read through the manual to actually get anything installed in this system here. But let's see. Okay, it's kind of a drawer type system here. So below this, there's a little bit drawer that you can actually pull out. And let's just see what's actually in there. Again, very nice unboxing experience. Very high quality box. This is where the drawer was actually inside the box. And yeah, you can't really dig deeper inside the box from the top. You need to use the drawer. Let's just move the box out of the way and see what was in that drawer. You actually get a power cable with this one. That was not something I got with my other NUC. I had a 12th generation Intel NUC. We do have a European plug in my country and this pretty standard PC power supply. A lot of power supplies also use this Mickey Mouse style. So that kind of tells me that this is probably one of the more beefier power supplies because it has one of those big plugs, not the smaller ones that we usually see with laptops. Below this one here, you can kind of flip it out of the way. What do we have inside here? This is where we have the VESA mount and the stand. Not really sure if I'm going to use the stand though, maybe just when I set it up. But yeah, pretty high quality stand. It's nicely labeled there with front here, towards the front. We do also have a Kensington lock, which is a little bit weird on a stand because you can just unscrew it right there. But yeah, it's a nice little added feature, a nice rubber feet all the way along the edges here. So it will stay on your table quite comfortably, and also rubber feet inserts here for the actual NUC computer itself. You can see those are actually quite nice. Well made. Again, always well made from Intel, I think. Other than that, of course, you do get a VESA mount, so you can actually mount it on the back side of a monitor. But you can of course also wall mount using this, but I believe its main purpose is that you can mount the NUC on the back side of the monitor. If you of course have VESA mounts on those, a lot of monitors, even if you use the included stand, actually use the VESA mount bracket, or at least the VESA mount hole, to actually hold that stand in place. So I'm not really sure how usable it actually is. You do also get a i7 sticker included as well. And then we have this plexiglass. I'm not really going to remove it, but I believe you can either draw on this plexiglass, like draw your own logo, or maybe print out a label and put it on here, and it will shine through the top of the lid of the computer. Default, it does have that skull logo, but you can kind of experiment with these, and there are multiple of them included. I believe there are 5 total, so you can kind of make your own logo and it will kind of light through the little NUC. Not gonna play around with that just yet, but it's definitely nice that it's included. And then of course we have the screw and the little Allen key as well. So you do have tools to at least remove the top lid. I believe below the top lid you need to supply your own Phillips head screwdriver. And then we have screws, of course, for the VESA mount to both screw it into your monitor, and the screws where there's only thread at the very tip is what you actually connect to the NUC computer, and those screws will actually rest inside the VISA bracket. You can see you have these screw holes there, and that screw will kind of just go in there and kind of rest against this and the NUC. Same design as with the other NUC I had, so that's pretty familiar. And then we of course have this very, very big power supply. And yeah, that's all we get included. So let me just at least remove the packaging here out of the way. But man, very, very nice unboxing experience. But yeah, you can see very big power supply. You can see compared to the computer here, they are maybe close to half as big as the computer, because it's not quite as thick as well. But man, you definitely have to account for a beefy power supply like this one here in your setup. I do kind of like that it has rubber feet underneath here, so it doesn't really scratch the surface, or the surface won't scratch the power supply. That's something I often do with my power supplies, just put a little bit of a rubber feet underneath here. And this is a very high quality light-on power supply at 9.5 volt, 11.8 amps. So that's 230 watt. Very, very beefy power supply. And we do have a, of course, barrel plug here in the other end. And Velcro ties here for the cable, built into the cable so it won't get lost. At least I believe it is. Yeah, you can see it's built into the cable. And we do have like these magnets on either end as well. So yes, definitely thumbs up for the power supply. It should be more than enough power for this little system here. Let's just get a little closer and let's have a closer look at the NUC itself. First off, let's go through the front. So we do have an IR receiver, which is definitely nice if you want to use this as a home theater PC connected up to your TV. You can use an infrared remote to control it. That SD card, UHS 2 right there. Nice placement, I think. And let's see how deep it actually goes. It goes pretty deep, so it doesn't really stick out as much, which is kind of nice if you want to leave something in there permanently. You can expand the storage that way, or of course easily transfer files from your camera and so on to the computer. There are some status LEDs, I believe one for network and one for hard drive, maybe one for power on. And we do also have some microphones built in. It's a little bit strange, but I suppose you could use it for like Cortana or whatever you want to use it for. We do have that Thunderbolt 4 on the front. Very nice that we have one on the front, and you need to use that, of course, to use Thunderbolt or faster peripherals, but also if you want to connect to the inbuilt GPU, you need to plug a monitor into either this one or the one on the back. We have two USB 10 gigabits per second. One of them is yellow, probably because it supports charging. We have a microphone and headphone combination out as well, and a power button that I believe also lights up. Nothing really here on the right side other than the Kensington lock, and of course a lot of air ventilation or air holes. Same at the front there, a lot of air holes as well. And the back side there also looks very nice, I think. We've got 4 more USB 10 gigabits per second. We have that nice 2.5 gigabit Intel LAN. You do have optical out as well. Thunderbolt 4 / USB 4. And you can also, like I said, hook up a monitor to this one here if you want to use the built-in graphics card. These two, HDMI and mini display out, is for the NVIDIA graphics card. And of course we have the power in socket for the included power supply. And other than air ventilations on the left side, we do not really have anything there. And then we get to the bottom side, and this is of course where the two fans resides, or sucks all the air into the system to cool the CPU and GPU. And I believe this should be a very efficient cooling solution. Should be pretty low noise and still efficiently cooling those two parts or components. So the graphics card and the CPU, of course, sharing the same cooler here on the back. And it just sucks air in from the bottom and blow it out towards the back. And maybe suck a little bit of air in through the sides and so on. It reminds me a little bit of a laptop design. Pretty much the same, but this one is a little bit thicker because it doesn't have to have a battery and keyboard and so on. So you can actually have a little bit of a beefier heat spreader on there, or cooling fins to blow air through, and the heat pipes and so on actually looks quite impressive. It seems to be all copper based. Also, like the base of the heat spreader is also copper, but I leave just all the fins back here is actually aluminium, and you can almost like see through there inside of the components. I'm not going to take it completely apart. In this video we're just going to install the SSDs and of course the RAM, which is a mandatory thing to get this up and running. So to get inside you need to remove these 8 screws here. And below that, I believe there is 5 screws more that you need to remove. You can of course use the included Allen key or Allen wrench to get into the top here. But to actually get inside the system, you need to use a Phillips head as well. I just prefer to use a screwdriver because I think that's a little bit easier. So let me just get inside here, moving all these 8 screws here on the top. Just like so, all 8 screws should be removed now. I'm just going to leave the screws inside, but you can see here, this is actually transparent. This is where, of course, the skull logo will actually light through. So actually quite nice when there's no light going through it. You can almost not see it, but you know, of course, whenever you turn it on, it will kind of be transparent. But this is just a plastic lid. Doesn't really help out with cooling or anything. It's just for aesthetics reasons. And then below that, of course, this is where we have the skull. You can actually remove this if you want to replace it with one of the other decals that's included, or you can, like I said, make your own with the other ones included. There's a kind of nice little feature, and also you can twist it around if you want the skull to stand upright. Of course, if you use the vertical stand, that could also be quite nice. And now I'm just going to put on my anti-static connection here from my arm, and I'm also going to use anti-static gloves just to be on the safe side. So the screws you need to remove are all labeled with numbers. So we do have 1 there, 5 there, 4, 3, 2. So let's just go reverse. So 5, and of course, now we need to use the Phillips head screwdriver. So let's go 5, 4, 3, and 2, and 1. Then we should be able to just remove this, kind of flip it over to its side right here, like so. Underneath here, we do have like thermal pads for the SSDs. That's nice, so you can transfer some of the heat away from the disk themselves. And the skull actually just fell off, and you can see they're very easy to take off and replace with something else. Maybe I'll put my logo on there or whatever, and just put it back into its frame here. So kind of a nice little design as detail. Didn't really have to do that. So let's start out with the memory. And these are dual rank 3200 megahertz kit from Kingston. I've had these in multiple systems now, and they've been working fine, both with Intel and AMD. So I'm pretty sure that these are actually working, just like so. And it does also say here that you only should use 1.2 volt. Then of course we have those 2 NVMe slots, M.2. The left one here can both do NVMe and SATA. The right one is only NVMe, and these both are only PCI Express Generation 3. So you won't really see any speed benefits plugging in a PCI Express Generation 4 into this motherboard, even though I believe the chipset does actually support PCI Express Generation 4, but for some reason they chose not to include it with this one. But anyways, I'm going to use this Corsair 1TB PCI Express Generation 4, but this is the first generation PCI Express Generation 4 drive. I've had that in multiple systems by now. Very high write endurance, but of course I won't really see any speed benefits, but that doesn't really matter because this is really just an overclocked Generation 3 controller on there, so it will actually suit the Generation 3 just fine. And we need to remove the screws first. This one can of course also use the longer NVMe SSDs, like most for servers and so on, but you have to remove this bracket beforehand because that will kind of get in the way, especially if you have memory chips on both sides. Just one thing to note, and this is going to be my primary drive. And if I end up running like RAID 1, I will of course just link them together. One down. Next off, Western Digital drive that I have pulled from my laptop. I had some time back. I never really used this drive, but it still is a nice 1TB drive, pretty high quality one. So it's a TLC flash one, and I think it suits this system quite well because it's just a Generation 3 PCI Express Generation 3 drive. So of course will work quite wonders in this system. And that's pretty much all you can do inside here. I believe this header is for some I/O stuff, but I don't think you can actually get something to fit in here, at least to my knowledge. And the Wi-Fi card is soldered onto the motherboard, so there's not an M.2 slot there you can use for other things like storage and of course upgrade the Wi-Fi card, but I don't really plan to use the Wi-Fi card. If you want to of course clean this system, fans and so on, from dust from time to time, you kind of had to remove everything, and it's kind of cumbersome, so I'm not going to do that in this video. So this is as far as I would go, but this is definitely a very nice setup. So all that's left to do, of course, is just to put this metal housing back into its place, like so. Yeah, just like that. Make sure there's no cables getting in, squeezed inside here. There, I think we're good to go. And then of course recommend going in the order of the numbers. So 1 up here in the top, 2 down below, then of course 3, 4 and 5, and just go through all the screws one more time. Make sure they're all nice and tight without them being over tightened, and that should be it. Of course, don't forget to put the skull back in place. And then the lid, of course, on top of that, like so. And then just screw in all of these screws. Of course, remember to change the bit for the right screws here. Pretty easy. I always like to cross tighten, but this shouldn't really be that important because this is just a lid. Doesn't really do anything other than just look pretty. And that's pretty much it. It should be ready for power now. So I have hooked up my keyboard here. I have connected my recorder to the HDMI out. We also have a power meter here so you can actually see how much power it actually sucks. The last thing to do, of course, is just to plug it in. So let's do that now. And of course, next step, power it on, but you can see they're just idling or in standby or powered off here. It does use a little bit of power. So it does switch around between 2 and 3-ish watt. Let's turn it on rather. You can see the skull logo nicely there. Let's just remove the plastic top. You can see it a lot better. And I'm just pressing F2. Hopefully we can get inside the BIOS. And you can see the skull logo also and the boot up screen. So inside the BIOS, it's pretty common for Intel NUCs to have a BIOS like this, at least more recent NUCs. And you can get a lot of information, of course, about the product. It does see the 32 gigabytes of RAM we have in here. If you go under advanced, it should also detect the two 1 terabyte disk we have, so the Force MP600 and the Western Digital SN730. Default is just set to balanced. You can see the fans are actually spinning right now. I can just barely hear it, but I'm not really sure if this is my recorder that's also kind of noisy or if it's the computer that is making the noise. But you can go very advanced here if you want to set up your own power profiles or temperature profiles. And of course we do have the performance tab here. It tells you everything about the system. So the memory speed is running at 3200. That is good. And we do register the two 16 gigabyte DIMMs. Because for security, you can set up superior password and we can set up all power related stuff here on the power tab. We also have a secondary power settings. And then of course we have boot, where you can enable or disable secure boot if you are not running Windows. You can see it's default enabled or enabled by default. Then you have boot display configuration as well and boot priority. So you can select what you want to boot. This one is selected the Ethernet as default booting device. Also, if you go under advanced, you have a lot more settings here as well. So of course we do have the settings for all of the onboard devices. So you can enable or disable the LAN or VLAN, Bluetooth and so on. This is also where you can disable the digital microphone if you don't want that. Not really sure why they have a microphone on a computer, but yeah, that's something they have. USB, of course, everything related to USB you can set up here. So you can enable or disable front USB charging. That's of course the yellow one there that could supply charging and so on and so on. We have the video settings there as well. So I like to set my iGPU to the maximum because I do have 32 gigabytes of memory. So why not let the iGPU be able to spend as much memory as possible or use as much as possible, because the iGPU can also still be very usable for using the QuickSync or using the video engine that Intel has if you want to do transcoding. So yeah, just give it as much memory as you can afford. We do have the event logs and we also have a LED control. So you can disable all the LEDs if you want to. Select anything right now. Maybe I need to go into the LED zones. Yeah, all LED zones are enabled. Software LED control is enabled. Let's just see if we can actually adjust the LED. So it's software controlled. Okay, I can't really do anything here. HDD LED is software controlled, software controlled, software controlled, software controlled. Apparently I can't really disable LED from the BIOS, but anyways, that's still pretty nice BIOS. I really like it. Nice graphical user interface. You can use the mouse as well to control it. You can see this fans actually spun up a little bit there. You can see we are hovering around the 60 watt, which is actually quite high. So let me just install Windows and then we can just run some benchmarks. I'm not really going to do any extensive gaming benchmarks. There are other channels that have done those for this specific system. So I'm just going to run some compute benchmarks. So Geekbench and Cinebench and so on. Try to stretch the system a little bit, see how hot it gets, and also see how many watt it actually uses under the different circumstances. So let me just get everything set up and let's get on with the video after that. So while everything is installing, you can see here in the background, I do have Windows Update currently installing, and you can see that quad-core CPU is definitely the biggest bottleneck of this little computer. It would be fine enough for like 95% of what I do personally. So for a little home office computer and occasional gaming, I think it would be fine. But of course, if you do a lot of multitasking, you can see here I'm just installing Windows Update, and it has been up in like the 100% utilization. Right now it's of course a little bit lower. But anyways, let's just have a look at the software. So this is the software you need to use to actually control that LED. So it's called the Intel NUC Software Studio. Right now it's just on default. I suspect you could make your own preset. You can of course enable or disable all the effects. Just turn off the light here so you can see a little bit better maybe. The skull on and off. You do also get system monitoring, so you can of course monitor your system. A little bit silly, I think, because yeah, you can just use the built-in from Microsoft to do so. And you can also set the different modes here. Choose the fan mode. So right now it's at balanced. You can of course set it to quiet or cool. And you can enable and disable the fans. That doesn't really make much sense to me. Disable the fans is definitely not something I would recommend. You also have the power mode here. So you have the low power, you have the balanced, max power, and you can make a custom preset as well. So you can just set the threshold here for the different amount of watt you want the board to actually consume. Max performance, of course, if you want to do gaming, to get the max performance, but balanced, I believe it's just balancing between low and maximum performance. Temperature wise, it's actually holding up quite well. It is a little bit hot right now, considering I just installed a lot of updates and drivers and BIOS updates and so on. But definitely not concerning at all. You can see 46 degrees Celsius on the CPU, 84 degrees Celsius on the discrete GPU. So that's definitely very acceptable for a small system like this. Of course, not really doing much, but yeah, you definitely feel the heat building up inside the case right now. So to get into more advanced LED controls, there's an arrow up here in the right corner. Click on that. And this is of course where you can go in and set up all of the RGB. So you can set power button to different colors. You can set the skull to different colors. Front LED 2 and front LED 3. So the LEDs here on the front, you can see the one on the left is the hard drive activity LED. The one in the middle is Ethernet activity, so the LAN you're connected to the back. And the one on the right here is the power limit LED. But anyways, let's just try and change the color of the skull. So you can change, of course, red, orange, yellow, green, and so on and so on. You can, of course, select solid, where it will just stay on. Breathing. You can even set the frequency for its breathing. So should it be slow or should it be fast? So I guess it will breathe like once every minute or something like that. And if you set it to 10, it will be very fast. You can also have it strobing. And you can also have it pulsing. Not really big difference between strobing and pulsing, maybe a little bit. So yeah, not the most intuitive lighting functionality there, but yeah, it's there. And you can also set the different modes. So if you wanted to show the power state, you can also get the skull to show the hard drive activity. So every time, of course, the hard drive is being used, either reading or writing, the skull will flash. You can also set it to Ethernet activity. So you can see that it's flashing every time there is some Ethernet activity, and so on and so on. And you can also just go in and completely disable it if you don't really want it. I don't mind it really. Not really sure that it's something I'm going to keep on. If I end up using this as a server, I'll probably just disable it or unplug it, but for now it's fine enough. We do also have the modern standby. So I believe if you put the system into standby mode, you can have it at a different lighting state. So it's default set to breathing. So when the system is just in standby, the skull will just be breathing to indicate that you are in standby mode. All the other LEDs, so the power button and the LED 1, 2, and 3, you have exactly the same functionality. And you can set the power button to whatever color you want. So exactly the same functionality for all of the different lighting features, including the LEDs here in the front for, of course, different power modes and hard drive and Ethernet activity. So everything is installed and up to date, and there's nothing really running in the background right now. And you can see there we are just hovering around the 18-19 watt idle, and that is with the NVIDIA GPU connected through HDMI. And that's better than expected actually. Let's just run a benchmark and start out with Geekbench 6. So this is the latest version as of recording this video. And let's run the CPU benchmark first. So Geekbench just finished, and let's just have a look at the actual temperature of the unit. Yeah, we are looking at 35, the hottest spot on top, 37 maximum on the top, and that's actually quite well. It is hottest on the front. We are looking at around 40 degrees, and below we are also looking into the 30s, so definitely very manageable. But this is of course only Geekbench, so that will only stress the CPU and only stress it a little bit. So not really the most demanding test out there. But in terms of result, we're looking at 1973 single core and 6149 multi-core. Not really all that impressive. Single core score is actually pretty good, but not that impressive multi-core score, at least not in 2023, when you have like all of these 10 core, 12 core, 16 core CPUs on the consumer market from Intel and AMD. But for like a daily computer and a small gaming rig, I think it is fine enough. Let's just run the OpenCL compute benchmark. And the Geekbench GPU test just finished. And we're also just looking around the 37-ish degrees Celsius, the hottest spot. So definitely very manageable, at least in this benchmark. And we're looking at 78,060 OpenCL score in Geekbench GPU test. Let's just run the same one, but this time use the Intel Iris Xe graphics, and let's just let it run here. And the Geekbench test just finished. Still just hovering around the 37 degrees at the hottest spot near the exhaust. So yeah, definitely not getting too hot right now. And we're getting 14,439, which is actually quite impressive, but only half of what NVIDIA were able to achieve. And this is of course only using OpenCL. For some reason, I can't really do the CUDA test. It doesn't really register it. You can see here if I go select my NVIDIA graphics card, it still only have OpenCL and Vulkan. But anyways, let's just move on to the next test. Next one I want to run is the Cinebench test. And this is Cinebench 2024. So this is the newest one. And we're gonna run all of the benchmarks. And this is gonna take quite some time. So of course I will speed this up. But you can of course see the watt meter and see what kind of power this system is sucking in various parts of the test. And we'll get back once we have the result. Just one note here, running Cinebench. Don't know if you can see that, but the power usage LED here on the right, that actually indicates how much power you're sucking from the device, is now more in the orangey mode. So whenever you're sucking more and more power out of this LED, depending on what LED settings you had it at, you can see green, not really sucking that much power, orangey, more power, and red, of course, is sucking a lot of power from the power supply. So that's kind of a nice little indicator there, so you can see how much power you are actually sucking from the device without actually having to go into a piece of software. You can just see if the LED is red, you know it is probably at its limits of what it's able to deliver. And Cinebench finally finished. Let's just have a look at the temperatures first. So we are still in the 40-ish temperature right now, at least towards the back. And below the unit, we're also in the 40s temperature. So that's definitely pretty good. And looking at the score, we are getting 4,179 in the GPU score, CPU multi-core 314, and CPU single core, we're looking at 81 points. That's still pretty respectable, I would say, considering this is only, like I said, a quad-core CPU. And just to compare here against other devices, you can see in multi-core workloads, we are all the way down here in the bottom of the list. We're actually not that far from like an i7 1260p, which is a 12-core CPU, but that's of course one of the newer architectures, so it does have the little big setup. So 8 efficiency cores, 4 performance cores. This one here is of course all performance cores, so you lose out on those efficiency cores. And Apple M1 is still significantly faster. Multi-core performance, but yeah, it's not really that far off. So like 200 points more. Let's look at GPU, and it's actually pretty comparable to the Apple M1 Max. I believe this is the full 32-core M1 Max, and the 2060 down below here, and you can see it is comparing CUDA versus Metal, but very comparable there in terms of its compute performance. Of course, the M1 Ultra is a little bit faster up here, and if we go up to the 2070 Super, it is, a few thousand points higher. And then we get up to the 4090, which is what I have in my other main gaming PC, and we're looking at 33,000. So that's close to like 30,000 more or higher points there, but I think it still is pretty okay again for what this is. Low power, small form factor, laptop-y design PC, which also of course does have a mobile CPU and GPU inside, very small form factor and very low cost, at least as of recording this video. And if we take a look at temperatures, we did get up to the 82 degrees Celsius max, and that is for the entire package. One of the cores actually got up to 83 degrees Celsius maximum. So I think that's definitely very acceptable. And the fans did spin up to around 1900 RPM for one of the fans. The other one only went up to 1700 RPMs. I'm not really sure if they are hooked up to the CPU and GPU here individually. There are two fans inside. It seemed like almost one of them is hooked up to the CPU and the other one is kind of monitoring the GPU. So it runs a little bit higher if they need to cool the GPU a little bit more. And for the GPU, we're looking at 67 degrees Celsius, and the hottest part of the die itself is 77 degrees Celsius. We did get up to the power limit of 115 watt, which is of course the maximum this GPU can supply or suck from the power supply. And if you look at the clock speed here as well, we went up to like the 1900 megahertz, memory 5500, and video 1700 megahertz. That's actually quite impressive, I think. Next thing I want to do is kind of just press this system, both CPU and GPU. So I just want to see if we can actually push the GPU temperature above the maximum threshold we've seen here, just running benchmarks. So that's 77 for the hotspot and GPU 67, and also for the CPU. Let's see if we can actually get it to run a little bit hotter than the 82 degrees Celsius, and maybe also see if the fan will spin up a little bit more here. And at the same time test the maximum power draw when we are maxing out both the CPU and the GPU at the same time. So I'm using CPU-C, which have a stress function here, so you can stress the CPU. So this will make sure the CPU is running at 100% non-stop. And we are running firmmark here as well, and this will just use the GPU to the 100% usage. For some reason, when running firmmark, it doesn't really utilize the GPU to 100%. I'm not really sure what the problem is here. Let's just let it run a little bit. So this is of course also a little bit extreme scenario, running the CPU and GPU at 100%. But like I said, you can see that the GPU is only really running at 20%. We are sucking around 172 watt from the power outlet, or the power brick. Yeah, I think Windows Activity Monitor is just way off here. If you look at the CPU ID hardware monitor, the GPU is currently at 100%. For some reason, Windows is only showing 20%, even though it is using 100%. So the fans just ramp up, and they are running 2100 for the GPU and around 2000 for the CPU. And you can see the current CPU temperature, 78 degrees, so close to 80. That's actually pretty manageable. And the GPU is using around 170 watt, and the entire system is using 175 watt when you're maxing out both the CPU and the GPU at the same time. Of course, this is only for this specific stress test here. It will of course vary depending on what kind of workload you are putting onto the system, but in this specific test here we're looking at just shy of 175 watt. So let it just run for a few minutes and see how high we can actually get the temperature. So it's now been around 5 minutes of this stress test. Let's just have a look at the temperature, and you can see there in sensor it is a little bit hot. At least the air going out the back here is up to the like 50 degrees Celsius, but the actual computer itself is only really around 37 degrees Celsius here on the top. And on the bottom, yeah, we're also looking at a maximum of 48 degrees Celsius towards the back. So the hot air coming out of this device is definitely very hot. Not really anything to be concerned about, I would say. So let's have a look at the temperature. You can see the GPU is hovering around the 77 degrees Celsius. The hotspot is 89 degrees Celsius, which is definitely very manageable. It just went up to like 78 degrees Celsius. And the clock, you can see here from the graphics card, it is a little bit lower now compared to like the boost clock frequency. So we're looking at 425 megahertz for the graphics, memory 5501, and video 1320. And you can see the fans now, they are spinning quite a bit higher. So 2366 for the GPU and 2160 for the CPU. So definitely those two have gone up quite a bit. And the temperature is up into the 80 degrees Celsius right now for the entire package. A little bit lower for some of the cores, but definitely very manageable, especially when you're considering the small form factor of this computer. You of course have to expect it running a little bit hotter compared to like a big PC, because all the components are just so close together. So all the different components will of course heat each other up much more in a small device like this. But I would say very manageable, at least after this short stress test here. So the next thing I want to test is the noise coming from this little device, which is kind of hard to do right now when I'm recording the screen, because the screen recorder I have over here makes a lot of noise. So for me to be able to let you hear the noise floor of the computer itself, I can't record the screen at the same time. So let me just turn off screen recording, run the CPU benchmark first, and you can listen to the noise floor, and then run the GPU benchmark and the CPU benchmark, and you can kind of listen to the noise floor when both the CPU and GPU are maxed out. So right now the computer is idling, not running any workload at all. Let me just bring you a little bit closer here so you maybe can hear the fans. So right now the computer is just idling, not running any workloads. Let me just be quiet for around 10 seconds so you can actually hear the fan noise. The fans are running at 800 and 900 RPM. So let me just start the CPU stress test. So the CPU is now at 100%, and let it just run a few minutes, and then you should be able to hear the fans ramping up just a little bit. So with the CPU running at 100%, the fans are running at around 1200 and 1300 RPM. Let's just enable Thermark stress test. So now it also have to cool the GPU on top of the CPU. So the GPU is definitely the hardest to cool. So let me just be quiet for a few seconds here so you can actually hear the fan ramping up. So right now the fans are running at 2000 RPM and 2100 RPM respectively. So this is about the noise floor you can expect when you're actually gaming. Maybe it will be a little bit louder when you're gaming for longer sessions, but at least in these shorter bursts you can expect in the 2200 RPM of fan noise if you're maxing out the GPU and the CPU at the same time. So to conclude this video, I really like this little machine, at least my first impression here. Very small and compact, very easy to install in, for instance, a server rack if you just wanted to run some containers for transcoding and so on, or running virtual machines, or also, of course, in your office or in your gaming environment. I think it will kind of fit in everywhere. Small, relatively silent, and also stays pretty cool, actually, for what it is, which is, of course, a very compact, small gaming PC, which is in a close to a form factor of a laptop. So of course it will run a little bit hotter compared to like a full desktop PC, but that is to be expected. I'm kind of happy that it doesn't have a 8-core CPU, for instance. I don't think it will be able to cool both that and the GPU at the same time. So I think it is quite okay that Intel have chosen to just use a quad-core CPU in this one here, which is still fast enough for everyday office work or desktop work, like browsing the web, emailing, Word, and so on. And you can maybe, of course, go a little bit above that. And of course, you can compute a lot more with that built-in GPU, which is actually still pretty powerful for the size and the form factor of this little machine. Comparable to an Apple M1 Max when it comes to the GPU performance. It's also relatively power efficient. It does get up to around the 175 watt on the full load, but I think that's definitely still very manageable. And then of course you do have that beefy power supply. It doesn't really get all that hot. It definitely does get warm to the touch, but not anything disconcerting at all. So yeah, if you can find this machine at a good deal and you know this form factor is what you want, I can definitely highly recommend it. I am looking forward to see how fast I can actually transcode my video files to H.265 using TDAR and this one as a node. I'm not really sure if I'm just going to run Windows and use it in my office here as a little Windows computer and also a TDAR node. I'm not really sure if it would be too loud for that, but definitely this is a keeper. I actually also ordered another one, so hopefully I can get that to the same insane deal. Just so much value in terms of being able to compute quite a lot with such a little device here. I really like the form factor. So I'll say if you can find it at a good deal, definitely go and pick it up. I think it still is an excellent machine. Of course, the biggest limitation of this one is of course the CPU, but that is, I think, very acceptable again in this form factor. But that's pretty much all I have for this video. I hope to see you again in a future one. Until then, take care.